Well, hello everyone and welcome back to Adrian's Digital Basement. On the bench today we have this, a TRS-80 Model 1. This was donated to the channel by Kevin, who actually drove all the way out from Nebraska to drop this off at my house, along with another Tandy machine, which I will show in the future. There's a video on the second channel where I actually give this a little bit of a test. I'll link it down below. And yeah, unfortunately, this thing doesn't really seem to work anymore. It doesn't even produce a good video output at all. So I'm gonna have to try to figure this out, but of course, if you saw my TRS-80 Model 3 repair video series, of course, there's a new diagnostic ROM that I created with Frank and David, which definitely will work on this machine and should help, at least to some extent, with troubleshooting. Although I think the video problem that's on here is unrelated and it's actually more like the video output chips that are problematic on this thing, or something else is wrong. I'm not even sure. Let's take a look inside and see if I can get this thing working. So without further ado, let's get right to it. The Model 1. It's quite a cool looking little computer, I gotta say. Let's see what the note says that we wrote last time. Bad video out, bad video RAM, good DRAM via diagnostic test. So that's a little bit of a spoiler because I have been working on a diagnostic ROM, which is right here, for these TRS-80 Model 1 and Model 3 machines. There's been a lot of videos on my channel recently with TRS-80 stuff, so if you haven't seen my TRS-80 Model 3 repair series, where I use the diagnostic ROM to help me troubleshoot and fix that motherboard, definitely check that out before watching this video. Let's refer back to the video on my second channel where I took this machine apart and did some very brief troubleshooting. That way I don't have to redo that troubleshooting here. And if you haven't seen that video already, I'll of course link to that in the description below, and I recommend you might watch that first. Here it is, and I have the little hand-take oscilloscope connected to this pin on the video output, which is actually the video signal. And when I hit play on the video, you can see that there's actually some activity coming out of this machine, at least at that point while I was doing that part of the testing. Now on the oscilloscope here, it's not very zoomed up, but you can see these pulses that are going down from this middle line. Those are the horizontal retrace pulses. Basically, in the video signal, it tells the monitor it's time to now sweep the electron beam back to the other side. And then these little pulses that we see here are actually video information on each scan line. Now, if I had zoomed up on that oscilloscope view to stretch the time base, I would have seen hopefully some actual information where the characters are being drawn on each scan line, but that's sort of a zoomed out view. Shortly after seeing that valid video signal on the video output, I hooked up an actual composite monitor to the computer, and when I hit play, all we're seeing is that right there. So that was the fault that was being manifested on this machine. Basically broke right in front of my eyes. Now here at this part of the video, I have the oscilloscope hooked up again, and notice there's no signal at all except for occasional pulses, which happen to coincide with the 60 Hertz refresh, the vertical refresh pulse that this monitor is getting. So basically all of the horizontal pulses and any of the information on the text seems to have disappeared on this machine. While the Radio Shack technical manual has the schematics for this machine, let's take a look at the SAM's computer facts schematics for it. Sometimes I find the SAM schematic to be a little more compressed, a little easier to look at, as opposed to the official one from Radio Shack, which is on multiple pages, so you gotta keep swapping back and forth to follow the lines around. Okay, so let's take the information that we know that we're seeing some video signal. We're seeing that 60 Hertz refresh pulse, but we're not getting anything else anymore. So if we go backwards here, we can see here there's like a buffer output transistor, 5 volts on the collector, and then the emitter here is what actually generates the video signal, and the base is the video signal that's coming from the computer. Well, we know that that transistor is totally fine because obviously we're getting that pulse, so that's coming through there. But if we keep going back a little further, here is another transistor that says sync amp. So that implies that the horizontal and vertical sync are coming through that transistor together, because this wire right here that goes through this 120 ohm resistor, this is almost certainly like the video signal, you know, with the characters, and all the sync is generated somewhere else on the schematics and come through this transistor. Now remember, from the oscilloscope, we went from seeing what looked like letters and both sync pulses to only seeing the horizontal sync. So if this transistor broke, then we wouldn't see any sync pulses at all, and we'd still be seeing the letters and stuff coming through this transistor. So I don't think any issues exist over on this section of the board. All right, so let's follow this over here. So this seems to be part of what generates the letters, like the text on the screen. Let's just ignore that for now and focus on the sync problem. So the sync wire goes down here, goes there, it is labeled sync. And if we go down to the next page, I think it's one of these 3 lines right here. Oh, there it is. So there it is. Sync picks back up off that line. And the sync signal seems to be generated by this very convoluted bunch of gates here. And I'm assuming this has something to do with like delays to get the signals shaped and looking perfect or whatever. And it's pretty convoluted, I have to say. But obviously, if any of these gates here, which part of Z57, 57, Z6, there's several ICs that make it up. If any of these are bad, well, then that could obviously cause an issue. Now, like I said, we're missing the horizontal pulse. So look, there's a horizontal drive signal right there, which goes into this whole thing. And there's a potentiometer there for horizontal centering, and there's a vertical centering one as well. And it kind of goes through all this, and then it actually gets combined together. And this is where the combination of the syncs are happening. So we can infer from the schematics that if any of these gates here are bad, all the way through here, this pot, all the way down to here like these as well, any of that goes bad, well, we're gonna lose our horizontal sync signal. Obviously this combination stuff, I guess this one could be bad because that's where it's combining, and that one could be bad because that's also a combination going on, but I don't think so. This has to do with like setting up the levels of the sync pulses and stuff like that, so it's probably not this stuff. So it could be one of these gates. Now when we get the computer open, because obviously I have it sitting here still all together, we can hook up the oscilloscope and take a look at the input pin here on pin 13 on Z6 and see if we see that pulse and kind of follow this along all the way and see if the pulse is there along the whole path. All right, so let's go back though to the problem that this machine is having, because not only did the pulse disappear for horizontal drive, we also lost the text. So if we look at this signal here for horizontal drive, and up here's the vertical drive, let's see where those signals are coming from and where they're used. So what we're looking for here is the horizontal drive signal. So there is one right there, and it goes into this counter chip, which seems to generate these L1, 2, 4, and 8. It's like a clock divider, it looks like. And vertical drivers right there. But what is generating the horizontal drive signal? Because when you look into SAM schematics, anytime there's a signal on the left side of the chip, that's input, and anything that's on the right is the output. So we know that the horizontal drive is actually going into this counter chip. I want to find what generates it. And there it is coming out of this LS93, which is another counter. So the lack of the horizontal pulse actually goes all the way back to this counter as potentially being a fault. And most likely this takes some clock signals. I see there's a counter on the input side and it looks like it's got a little feedback going on. I'm not super familiar with the way that this LS93 actually works. I mean, it says it's a counter there, but it's probably doing something with dividing clocks, or somewhere in this circuit. It's taking the clock signal for this machine and then it's dividing it down to get that horizontal pulse. But because the horizontal pulses, I think, shouldn't happen during vertical retrace, there's probably a little bit of relationship between this chip and something else that has to do with the vertical. Anyhow, I'm gonna mark Z50 as a potential problem. Now, we're not getting any letters or text on the video signal anymore either. So let's go take a look at that section of the schematic. I gotta find it. And let's see if it relies on the horizontal pulse as well, or the horizontal drive signal. It almost certainly does, because if you think about it, when the computer is drawing text on the screen, it has to be perfectly aligned with those horizontal pulses. Otherwise the text is gonna jitter and move all around the screen. So zooming out, this is the video memory right here, the 2102s. So we're in the right section for like where the video is coming from, the text that is. So we got a flip-flop here. We should have like a latch or a mux or something. Let's see, shift registers, character generator right there, look at that. And take a look at this. There it is, there's the horizontal drive there. That's one place it's used. And it goes into this O2, which goes into this flip-flop, which is all definitely part of the text generation circuit. Absolutely is. In fact, I'm also noticing here, See this like L124, there's an L8 over there. If we scroll back over to that chip, well, where's the horizontal drive chip? Vertical drive, horizontal drive, here it is. I thought it was generating those L signals. Oh wait, you know what? It was down here. Horizontal drive goes into this chip, and then what comes out of it? L1, 2, 4, and 8. And those are absolutely used in that section of the board as well. So I'm gonna say that this counter is possibly suspect, because say this chip goes bad and it holds that horizontal drive signal to ground, for instance. Well, then basically these L1, 2, 4, and 8 signals aren't gonna work. Horizontal drive signal's not gonna work. So it could be that chip. But I'm kind of leaning towards where the horizontal drive signal is coming out of, which is this Z50 again. So right back to that Z50. Everything is kind of based off of what is coming out of that. There's even a picture right here. So we've got 5 volts should have a pulse at 10 microseconds here. So that's one of the reasons why I like the SAMs, is they actually kind of give you a, sometimes very hard to see, but there is a picture of what type of signal you should be seeing at least. Okay, so I think I have a good place to start with troubleshooting this machine. Next step is let's reopen it. Okay, as I talked about in the last video, the keyboard is permanently attached with this very flimsy ribbon cable. This is the Rom Upgrade here, which was an official Radio Shack upgrade. We're gonna just lift this whole computer out. Oh, you know what? Again, this is tricky because if I lift up the keyboard here very carefully, there are these little rubber things down here, which are surprisingly supple. So this machine was cared for well. And we gotta slide these off first before we can lift the motherboard out of the computer. Now, all these wires and stuff you're seeing here, that is part of this upgrade here. I think, yeah, this is for the ROM upgrade, I'm pretty sure. And this other one goes to this other little board right here, which I haven't figured out what that does exactly. I'm sure someone watching is gonna be able to tell me. But you just lift this out. There are no screws or anything holding it into the case. So as you can see here, the machine is in really, really nice condition. No corrosion. This thing did not get stored out in a shed where it was exposed to moisture and whatnot. So things are looking really good. Again, this is the ROM upgrade for the level 2. So the original machine had 2 ROM chips right here, but to get level 2 basic, which adds a bit more ROM space, so it's a more capable basic, I think. Basically, you gotta have this mod. So you take the ROM chips out of here and you run this cable. Alrighty, let me try to find Z50 from the schematics, and I think it is under this cable here. And there it is, there is Z50, 1978 19th week, 74 LS93. Now, even though the ROMs are obviously removed from this machine, I can still power it up, and we would expect just to see a full screen of garbage if the ROMs weren't working. That's just like that TRS-80 Model 3, to be honest. When you first initialize these machines, the video circuitry should just read the video memory directly out. So whatever junk is in the video memory should be displayed on the screen. Let's see, so there is the chip right there. Pin 11 that we're looking for, that's the horizontal drive on Z50. And let's turn this on. Oh, we are seeing output on the horizontal drive pin. And when we zoom in, we're getting 15.8 kilohertz, which, well, if you know your NTSC scan rates, 15.7 kilohertz is the standard, and I know this computer runs a little fast. I kind of have to wonder if this thing is actually working right now, because that failure that happened last time kind of wasn't there and then appeared. What if this machine is actually working now? Well, it won't be too hard for us to figure out the fault here. So this is the video output circuit right here, which is right here. This is the video output connector, and I have a feeling these 2 transistors here are probably these 2, Q2 and Q1. Well, unfortunately for these 2 transistors, it is not labeled what's what. So the emitter, let's look at the emitter on this one first. Let's power this up. Oh, look, that sure looks like a video signal right there. So this machine, I'm gonna say, is actually working right now. That's really disappointing for a repair video. I mean, it definitely failed in the last video, but now it's freaking working. What the heck? That is not cool, Radio Shack, not cool at all. Now, it's interesting, it smells hot, like this machine, I don't know, I smell a lot of warmth here, so I should feel around here carefully to see if anything is like burning hot. And it's like the heat smell is sort of coming from this area of the board here. What is really warm? Bridge rectifier, that's warm, but that's normal. These ICs are not hot. Huh. Yeah, I'm not sure what's actually making that smell. That could be just because this computer hasn't been used in a while or something. I don't know. And let's get a monitor, or let me get a video signal hooked up to the computer here, to the video capture device. So let's see what this thing is doing right now. And maybe what I need to do is just let it run a little while. Maybe this is like a heat thing that causes a chip to fail. And that's what happened last time on that first video. Okay, so this is connected to the RetroTink. We have color bars, and let's plug in the power cord and let's see what we see. We should be getting some garbage, text garbage. It's what I expect to see. There we go. So I was wrong earlier when I said we were going to see garbage. I think the default behavior when you have the ROM removed from this machine is you get all at symbols, or if it's in 80 column or 64 column mode, you see ats and sixes, I think, like that. It's something to do with the way the lines are pulled high or whatever, and the CPU is basically going through an endless loop. It's like a no-op or a NOP generator for the Z80 when the ROM is removed. So I think what I want to do now is I want to try to plug in my diagnostic ROM. Now, what I haven't tried with this, and this is the latest version available from the GitHub repo, which of course I'll link to in the description below. This one is fully compatible with the Model 1. It auto detects that it's a 7-bit video memory Model 1, which is what this one is. So this one fits within a 2K ROM, and I think with this adapter, I should be able to plug this into here and actually have it work. If not, I'll have to reconnect this ribbon cable and then plug this in on the other side. So let's give this a try. Let's kill the power. So that's off. And let me push this into the motherboard here. There we go. And let's turn it on and see what happens. Oh, yeah, it's running. Okay. So, video RAM tests good. And now it's testing the first 16K of DRAM, because that's what this machine has. If you have an expansion interface, then you obviously have additional memory. So as you can see on the test here, it now has, wait, what's going on here? Why is it flickering? That's weird. It's still running though. It says bit errors on bank 2 and 3. Like it has 3 banks of memory. One bank is this bank right here, and the other 2 are on the external expansion interface, which obviously aren't connected. So it's normal that banks 2 and 3 are gonna be all errored. But what's cool is I do know now that it's possible to run this diagnostic ROM directly on the motherboard without the level 2 expansion ROM thing connected at all. So if your machine is actually a level 1 Model 1, then this ROM does work plugged straight into the motherboard. The one caveat is when you program the EEPROM, as I'm using here, or the EEPROM, I am using a 2864, or a 2764 would work in it as well. But when you load the ROM images, you actually have to load the ROM up in the 1000 address space. I actually have 2 copies of it, so it's loaded down here at all zeros, and then I have it loaded up at the 1000 as well. And when you're doing that with, say, the Mini Pro software, the one thing you have to do specifically is when you go to open, you open the ROM chip, you need to turn off the fact that it's going to clear the buffers. That's the default behavior. So you want to disable it, and then what you do is you type into there, and we're going to load it at 1000 address. It's not this top box, it's this bottom one. And when you hit OK, that loads the ROM fully into that second half of the ROM. We're basically using only 4K of this 8K EEPROM. Going back to the video capture, I see that the diagnostic is still running. So I'm just gonna let this sit here for a while, maybe an hour or so, and I'll come back and see if we still have a valid video signal. It'd be very annoying if this problem went away and stays away, because the fact that it happened once means that it may easily or probably will just come back again. So the machine's been running for a while, and yeah, we still have a good video signal. So that's kind of annoying. Now, when you look at the captured video, you might notice there's a little bit of waviness. Now, I think that has to do with these potentiometers right here. I think one of these potentiometers is the horizontal position. Okay, when I touch that one, it kind of blanks in and out. And I think this other one here is the horizontal position, or the first one was the vertical position, and that one is the horizontal position. So I think it's time for some QD electric cleaner here on those 2 pots. I'm just gonna try to clean them a little bit. They're probably scratchy. So back and forth a little bit, both of them. Alrighty, let's turn it back on. Now they're probably so far out of position. Oh no, that's okay. So let's see, let's get this back into position. Now, it might well be that that jitteriness is just part of this machine. Like there's no way to fix that because it seems like no matter how I have this adjusted, it keeps blanking out. It kind of jitters anyways. Oh, that's better now. That's better. Okay, let's do the vertical position. I think the RetroTink is going to be unhappy with me adjusting this. I think to try to give those pots as much help as possible, I'm going to hit them with some of this. This is Deoxit Fader Lube. Okay, so machine is powered up. Is this any better now? I don't know. It's not great. Like when I have the position way over to one side, it's starting to wrap around there. It seems like there's less wobbly jitter, but in the middle, as soon as I let go of the pot, it kind of starts to jitter a little bit. Let's move this up. It's probably not really possible to get this perfect, and it's just because those are analog adjustments, and ideally, this should be dialed in with some resistors. So I suppose if I got this dialed in perfect, like with the monitor hooked up to the real monitor, then I could just replace those pots with some actual resistors. But ultimately, yeah, I think the fact that there's pots probably causes that jitter. So if you have a Model 1 that got a little bit of jitter going on the sides, check those pots, try to clean them, see if that helps at all. Otherwise, back to the machine and that video problem, it just does not seem to come back. The thing has been working fine all this time. No particular chips are hot. So I don't really see what could be the problem. So I think at this point, I'm gonna call it self-fixed. And I think the next thing I wanna do is upgrade this to 8 bits of video memory. Now I'd found some old articles about converting this thing from 7 bits of video memory to 8 bits. And here's one of the articles here written by this gentleman, Richard Barker and Donald Stoner. And it even says here that an early brochure for this computer actually mentions that it has uppercase, lowercase, but it seems that Radio Shack like saved a little tiny bit of money by eliminating that extra bit of memory, that extra SRAM chip for the video memory, and they just gave it uppercase only. The article goes on to tell you how you can implement the mod on this thing, and essentially you're going to be attaching another 2102, which is the SRAM chip for the video memory, which is right here, and another 7486 and some wire and a switch. And it looks like the reason why you're going to have a switch, and I'm just sort of scrolling through here, I think it has to do with the fact that some very early programs don't work properly when you're in lowercase mode. When you have the lowercase enabled, you're gonna get some weird characters. And that's because if we go back to the test ROM here and notice that it's repeating the entire character set twice. Well, it turns out that if your program uses the wrong character set to draw the uppercase letters, what's gonna happen is all of a sudden, you're gonna have a bunch of garbage instead once you enable the lowercase ROM. And it's because I think what happens is that this first set of letters here become special graphic characters, and we get lowercase right there, and then we have the uppercase and then the numbers or something like that. It switches around a little bit. So obviously this ROM is drawing the text on the screen using the same routines that work on the Model 3, which has lowercase. So later programs, and Level 2 Basic for that matter, work fine with the lowercase mod with all 8 bits of video RAM, but the early stuff doesn't. So I think they wanted you to do this whole switch thing to turn off and on the lowercase. We don't need to do that. I'm never gonna run programs on this that don't work with the 7 bits. I just wanna have the 8 bits to have the lowercase letters always working. So looking back at the SAM schematics here, here's the video RAM chips, and you have D0 through D7. Notice that D6, or bit 6, is missing. And right here, there's a gate here, Z30, which generates the like fake bit 6 basically, that goes into the character generation part of the circuitry on the motherboard. So you see here, bit 6, it goes into these 2 tri-state buffers, and if we zoom out a little bit, basically the character generator is like over here, and you know, all of that stuff handles that. So the fact that it's like kind of making a fake bit 6 means that those letters are doing that repeating pattern. And it was a good solution to like save a little bit of money for one less SRAM chip. It's possible back in the day, like in the early 70s, those SRAM chips were like $5 a piece or something, or $10 a piece. So across all of these TRS-80 machines, lowering the price by $5, $10 or whatever it is, let them hit that price point of whatever it was, like $600 when this computer came out, which was a lot cheaper than I think like the Apple II at the time, which of course it didn't have lowercase either. Anyhow, what I've gone ahead and done is I grabbed one of these chips here and I bent out the 2 extra pins. And the reason why I did that is because if we look at these chips on the schematics, you can see that most of the pins here, well, they're not labeled. It's like address lines and stuff like that. The only relevant things is pin 11 up here and pin 12, which is like the data bus connection for the RAM chip and I guess the output. I think one's input and one's output. The intent is to take this SRAM chip, basically piggyback it on top, the machine's off right now by the way, piggyback it on top of one of these existing chips here, so it gets all the address lines and the power and the ground or whatever else it needs from the chip below, but then we have those extra data bits, the in and the out, that will just connect to appropriate places onto this motherboard. And I'm thinking this should be a very simple mod, a lot simpler than that instruction talks about with all the switch and stuff. Don't need that. So I think I'm gonna piggyback on top of like D5 or D7 here. And then we don't even need this entire Z30 part of the motherboard. In fact, what we're going to do is cut the trace that's coming out of pin 13 on Z30. And that is where we're actually gonna solder the wire that would come off of pin 12 off this piggyback chip right onto that pin. And then for pin 11, we need the data 6 line, and we just have to find something that has it. Here we go. It's right here on Z60 here on pin 5. So we just need to go from pin 5 to the other pin on there. And I think that should do it. Okay, so that is it. That's pin 13 right there. It's a 14 pin IC. I'm gonna cut this in a way that will be easy to solder back together again if I need to, if this mod doesn't work. But there we go. When we take a look at the motherboard here, Z60 here, that's bit 6 and it has D6 on it. And it's this IC right here. I've actually marked the 2 pins right there that are relevant. I think what we can do is literally put this RAM chip on here and I'll just do 2 flying leads from there and there to there and there. And with that cut pin on this IC, I think that might actually give us lowercase. I think that's pretty simple. I guess before I attach this chip, let's just see what happens when I turn on the computer now with that bit 6 line cut on that IC. All right, so there it is. Notice we have lowercase now. So it's uppercase, lowercase, uppercase, lowercase. So it's still repeating, but that's because we haven't installed this chip yet here to give us that extra bit that should allow us to have all 255 characters that we need. So I think I'm on the right path here. For soldering this chip on, it actually doesn't matter which one we do it on. Now I've just piggybacked that chip on there. It's just sitting on there right now. And you know what we can actually do is I can just attach the wires right now before I actually make any solder connections and we can see if this is even working. I am not 100% sure that this chip works. I actually borrowed it, or I took it off the RAM card from the Southwest Technical Procs PC. It was the RAM card that I removed from the system because basically I added that 32K RAM expansion on that thing, and this thing was like a 4K RAM board or something, so and it had some other bad RAM chips on it. So basically, I don't feel that bad to steal that chip. It's similar vintage to this motherboard, so it's time appropriate. And ultimately, to get that RAM board on the other machine working again, I need to order at least one of these chips. So I'm just gonna borrow this. Okay, there we have it. So the RAM chip is just sitting on top. See, it's not actually connected, but the wires are connected. So if I hold this in place and I start the machine, maybe that diagnostic ROM will see all 8 bits. Okay, here we go. Look at that. It worked. No, it didn't work. Well, no, I don't know. Is it working or not working? I'm actually not sure what's going on here. So, and when we look at the character set, it looks correct. It's got a bunch of Greek symbols, then the numbers, then it's got uppercase, and then it's got lowercase, and then it has all the graphic symbols. I think that's all the character generator on this machine can actually give us. But we're getting some weird symbols, like it says 16K on the first bank, but instead of a K, there's a down arrow. So I'm not 100% sure what's going on here exactly. Let me power cycle the computer again. I mean, it looks like it's seen all of the bits. I suppose it's also possible that not all of the pins are connecting or making contact when I'm piggybacking the chip here. Yeah, okay, so it's making bad contact. You know what? I'm gonna go for broke. I'm just gonna solder this on, and I think this is gonna do the trick, I think. Alrighty, some clumsy soldering. I think that is on. The wires are attached again. One of them came off while I was moving them around. Okay, moment of truth. No. It doesn't quite work. That is weird. Guess I need to do a little thinking here to see what I've done wrong here that's causing this to kind of work, but not totally work. Like I'm seeing that the R for Frank has an @ symbol as opposed to the R, which honestly really feels like that is simply a bit error. But I mean, maybe this chip is just bad. Maybe I should have been, oh dear. Or maybe it's too slow, or there's like some other problem with it. I mean, there's no kind of weird jittering going on the computer. Definitely mostly working. So I think my concept is sound. But yeah, clearly it's not fully functional here. Alrighty, we have the Retro Chip Tester Pro out, and here is the IC I removed from the board. The pins are a little mangled, but it's okay otherwise. Aha, look at that. Look at that. I should have just tested this first. You know, when I was working on the Southwest Technical Products PC, I thought I had identified which chip was bad on that board, but I guess I didn't. So let's go to the board here and steal another chip off of it. That sucks. I really should have, you know, tested them before I did all that extra work. All right, here's the next one here. And this one's doing March testing here, and it's looking good. So this chip, this one works better. Okay, live and learn. When you have a chip tester, use it. Okay, with the new chip, I'm gonna try to do a piggyback test. Let's see what we get. We got, yes, it's working. Boy, I was doubting myself that my my work with my little bodge wires was actually functional. But clearly, this chip here, which did test bad, was actually bad. Let's just make sure after I applied the heat that it actually works. This is the bad chip here. Here we go, fingers crossed. Please work. Oh yes, 8-bit. So it tests the RAM properly. Now this particular diagnostic ROM that we came up with actually is doing a March test on the video RAM, which as you saw on the Retro Chip Tester Pro is one of the final stages. And this bad chip here was actually testing good with the regular bit pattern test, and I think it failed on the random test. But the March test is the most comprehensive. I'm gonna argue it's one of the most comprehensive ones, and it will detect all of those weird page bit errors where basically one bit in somewhere in the RAM chip is interfering with another bit. And look at that, it worked. So if you have a TRS-80 Model 1 with only 7 bits of video RAM with no lowercase and you want to add lowercase, all you got to do is order yourself a 2102 SRAM chip, a good working one preferably. Bend out pin 11 and 12 on the new chip, solder it on top of one of the other video RAM chips, run 2 wires from 11 and 12 over to chip Z60, and you connect pin 12 on the video RAM chip to pin 4 on 60, and then pin 5 on 60 goes over here to pin 11 on the new video RAM chip. And then you go up here to pin Z30 and you cut pin 13, and you use some sharp cutters like this one. That way you can reconnect this later if you wanted to. If I just remove these 2 wires right here or disconnect them and I reconnect that, that would turn the machine back into a 7-bit machine. And actually, if you don't want to cut the leg on this IC up here on Z30, all you need to do is take it out of the board and put it in a socket, and then you can just bend pin 13 out and leave that hanging off the side. and that would have the same effect. You don't even have to put a single bodge wire on the bottom, no traces are cut, nothing. It should just work just like this. All right, with that, I guess this machine works. It was sort of a repair that wasn't. I'm going to put this thing back together so we can actually try some stuff on it. I put the computer back into its lower half of the case here, and I booted up into BASIC, and it worked. Not quite working perfectly, but I'll get to that in a second. And I turned away, and when I looked back at the computer, I just saw color bars, and the machine was still turned on. So I have the oscilloscope hooked up right here, and if I turn this machine on now, there it is. The fault has come back. Is this like Murphy's Law? At least I didn't put the computer back together fully, but the problem that was in the original video is back. And kind of like last time, I had actually a working computer and I was typing, hitting enter, you know, it was seemingly working perfectly with the original ROMs back, and I took the Diagnostic ROM out. And yeah, now it's broken again. So I guess let me take this computer apart and let's examine those signals on those chips, which I thought might be the culprit at the beginning of this video. All right, here we go. Let's see if this has a signal. It does have a signal. Okay, so let's take a look at the emitter. All right, and definitely the emitter, the video signal, we are just seeing that pulse, the horizontal pulse. So that definitely means, let's see here, that the H drive signal is coming out on pin 11 here. Let's follow that down, let's see, to here. Let's look at pin 14 on a Z12. All right, Z12, pin 14, that should be the input. All right, that signal looks good, it's as expected. Now let's check these L1, 2, 4, and 8 here out of this Z12 here. So I'm on pin 12 here. Okay, that looks normal. There's pin 9, and it looks normal. As you go down the pins, the pulses should get wider and wider. And there's pin 12, and yeah, it's very wide. I'll have to change the time base to see it all. There it is. All right, so that looks like it's working. Let's keep going down the path here. So let's look at Z6. This is the horizontal right before it gets combined with the vertical. So let's look at pin 9. All right, so pin 9, that is the correct input signal. Let's check pin 8. What's going on here? So 9 right there. Let's take a look, 15.8 kilohertz. This is just an inverting gate here. So it goes in 9, comes out 8. You should be seeing low with high pulses, which is the opposite of that. And look at that, nothing at all. So yeah, and let's look at Z57 pin 8, which is the vertical pulse, which I'm sure is working. That chip is this one right here, Z57 in the bottom corner of your screen. So that is the output of the vertical, and this is the reverse, the input to it. Yeah, so that is working as expected. But once again, there is the input looking normal. There's the output not looking normal. Both of those signals here, 8 and 8, go and they combine with these chips right here, Z5. So it is possible that Z5 is causing a problem because it goes into pin 2 right here and also pin 13 right there. So I think the best thing for me to do is just snip pin 8 here, and then I'll be able to see if the output that's coming out of the IC package is driving low. And then if I resolder that together and it just is high again, then it could be Z5 that's causing the problem. Okay, Z6, pin 8, which is the output. I'm about to cut it. All right, I have the probe on the top part. That's the leg that's coming out of the IC. Let's see if we have a signal now. Aha, we do. Interesting. And then on the lower part, below the cut, it's all high. So that kind of implies actually that it is what, Z5? That is the problem chip, not Z6. All right, let's do a little test, the multimeter on ohms. I'm gonna go from the motherboard there on Z6. This is the part of the trace that's actually going to Z5 on pin 2 and on pin 13. and I am touching it to the VCC pin, which seems like it's what it's getting pulled up to. And okay, we're getting 281 kilo ohms. So I almost have a feeling right now, if I reconnect that pin, like I solder it back together, I bet you this thing will be working again. So this is like some kind of an intermittent heat problem or something. All right, I've gone ahead and I reconnected that pin. Let's see if we have a working signal again right here. Yep, it's freaking working again. Now let's look at the emitter on the video output. And there it is, we have a normal video signal. So like this fault is very intermittent, and just having the computer out for a while seems to have fixed it. And the weird thing is I had this computer on for like an hours at this point, and it didn't stop working. I think the next course of action to try to figure out which of those is bad is have the oscilloscope connected to the emitter there. So we have the video signal. Let's get this synchronizing the pulses properly. There it is, okay. And I'm gonna grab the hot air thing here. I'm not gonna put it to like 350 degrees. I'm gonna turn down the temperature to about 100 Celsius here. And let's heat up those chips and figure out which one of them is the problem. Is it Z5 or is it Z6? It's not really doing anything. Well, I heated it up and we still have a normal video signal. Let's try the other one here. Okay, this is ridiculous. Oh, did you see that? The video signal was getting weird there. It was getting weird. Okay, that is a hot chip now. Now the thing is, these chips don't get that hot in normal operation. Like whatever the series is, when this computer is working, they're pretty cool to the touch. So I'm definitely heating them up way hotter than they normally get. And nothing is really changing. Wow, this doesn't make any sense. It is not misbehaving at this point. It's working just fine. And the whole board is, wow, it's really hot now. All right, well, this is a weird and frustrating problem. I know the problem exists in that general vicinity. It's gotta be one of those chips, because as soon as I cut that leg, then Z6 was now outputting the signal properly. And as I mentioned with the multimeter, I was able to see about 12 ohms between that pin, the pin on the motherboard, not on Z6, and 5 volts, which actually that kind of tells me right there that Z5 has got to be the problem. It's got to be these ones right here, these input pins, either 13 or 12, that is causing this issue. But it's so weird that heating up the chips, which are still quite hot by the way, had no measurable effect. I saw a little bit of a change, but yeah, I don't know. I guess I just need to leave this thing running for longer and see if this problem comes back. And I'm going to stick the diagnostic ROM in here so it's at least doing something while it's sitting there. There's something else I'm noticing is that this little transistor right here, which is labeled Q3, gets really, really hot. All right, we're here on that section. There's Q4, there it is, Q3, regulator drive. Why is that so hot? This is generating the 5 volts, okay. Q3 along with Q4 is generating the 5 volts. The weird thing is Q4 is this large package right here with this heatsink on it. That's not getting hot at all. How about this one over here? That's sort of warm. Ow, but that is burning hot. That cannot be right. Looking at Q3 on the schematics, this is like driving the base of this large one. So it shouldn't be handling a ton of current at all. All right, I think I'm gonna take a little bit of a break right now, analyze the schematics, try to figure out why that part's getting hot, and also try to come up with a strategy for figuring out why we're losing the sync signal. Well, I think I'm gonna end this video here. I think it's gonna be around 45 minutes when edited, and I was really hoping to finish this machine up in one video, but turns out some of these problems are a little bit beyond the quick troubleshooting I was hoping it would be. So we're left with a few different problems with the machine. We have that intermittent fault where the video signal goes away. And to be honest, I'm not sure if the machine is actually running anymore while that fault is there. I should have had the sound hooked up to hear if the diagnostic ROM was still making its normal beep codes. And then the other problem, obviously, is that voltage regulator is not working properly. It's weird, the machine is running, like there's 5 volts on there, but that one package is getting incredibly hot. And then the large transistor, which is actually what's supposed to be dissipating the heat to regulate the 5 volts, isn't even getting warm at all. So clearly something is wrong in that department. And maybe those two problems are related. I actually don't really know. And there is actually a third problem, which I just sort of breezed over. But when I had it working just briefly, when I had done the video RAM upgrade to 8 bits, when I booted into BASIC, all the characters were gibberish. Now, I think that is a problem that is with these original ROMs that are on here, and I just need to get some new ROMs made that can upgrade this to a later version of BASIC. But it's really weird how, like, the documentation from back in the day that talks about doing the video RAM upgrade doesn't really mention the fact that BASIC is going to use the wrong characters. But I found a couple mentions of it after a lot of Googling that is in fact the case with this machine. So I think in the next part, I need to attack all of those issues and we'll hopefully be able to finish this machine up, which, again, I'm really shocked. I thought this was going to be a very quick video, and well, here we are like 40-something minutes later, and it's still not fixed. So if you enjoyed my troubleshooting steps, which were maybe not so good or good, I don't know, thumbs up would be appreciated. If you don't like it or you didn't like what I'm doing here, you know what to do. Huge thanks to my patrons. Their names are showing up the screen. And of course, a big thanks to Kevin, who brought this machine to me, along with another cool TRS-80 machine, which I will need to get to in the future. And I'm definitely going to get to it. I hope I'm not burning out my channels or my viewers on TRS-80 content. The Model 3 repair videos and diagnostic ROM video I made seem to be doing quite well on the channel. So that's good. We'll see how more repairs do when this video is posted. I think that's it. So hit that subscribe button if you haven't already. And yeah, that's going to be it. So stay healthy, stay safe. I will see you next time. Bye-bye.